A massive limestone quarry supplies the raw material for cement production. Industrial drilling machines prepare limestone layers for controlled blasting. Excavators collect broken limestone from the quarry floor. Controlled blasting breaks solid limestone into manageable rock fragments.
Heavy dump trucks transport limestone across the quarry site.
Dump trucks deliver limestone to the cement plant intake zone. Limestone is unloaded onto heavy-duty conveyor belt systems. Conveyor belts move limestone toward the primary crushing unit. Magnetic separators remove metal contaminants from raw limestone. Raw limestone enters the primary crusher for size reduction.
Processed limestone moves toward covered storage and blending zones.
Automated systems regulate limestone flow for consistent processing. Crushed limestone exits the crusher in uniform sizes. Limestone is now prepared for raw mill grinding operations. Raw materials enter the vertical raw mill for fine grinding. Airflow lifts fine particles upward inside the raw mill. Heavy rollers grind raw materials into a fine powder. Additional raw materials are added for precise chemical balance. Coarse particles fall back for additional grinding cycles.
Ground raw meal is pneumatically transported to blending silos.
Blending silos homogenize raw meal for chemical consistency. Fine raw meal exits the mill through controlled outlets.
Air injection systems mix raw meal evenly inside silos.
Quality sensors continuously monitor raw meal composition. Raw meal begins heating before entering the rotary kiln. The preheater tower prepares raw meal using rising hot gases. Homogenized raw meal flows toward the preheater tower. Homogenized raw meal enters the rotary kiln through sealed inlets. Raw meal temperature increases as it advances deeper inside the kiln. The rotary kiln slowly rotates to move raw meal forward. Hot gases begin heating raw meal inside the kiln chamber. Fuel burners generate extreme heat for chemical transformation. Raw meal begins partially melting under extreme kiln temperatures. Chemical reactions convert raw meal into clinker compounds. Hot clinker falls directly into the clinker cooling system. Clinker nodules grow as material rolls through the flame zone. Fully formed clinker nodules move toward the kiln outlet. Clinker exits the rotary kiln at extremely high temperatures. Clinker temperature begins reducing through controlled cooling airflow.
Stabilized clinker is now ready for final grinding processes.
Hot clinker spreads evenly across the cooler grate surface. Cooled clinker moves forward along the cooler discharge path. Clinker temperature drops rapidly as cooling air circulates. Powerful fans force cooling air upward through hot clinker. Recovered hot air is redirected back into the kiln system. Cooling efficiency stabilizes clinker mineral structure for grinding. Secondary air from cooling supports combustion inside the kiln. Metal detectors inspect clinker before final grinding stages. Clinker exits the cooler at controlled safe temperatures. Conveyors transport cooled clinker toward the cement mill. Cooled clinker is temporarily stored for process balancing. Automated gates regulate clinker flow toward grinding systems. Clinker is now prepared for final cement grinding operations.
Cooled clinker is transferred toward the cement grinding section.
Rotating mills crush clinker into fine cement particles. Clinker and gypsum enter the cement mill together. Grinding media reduce clinker size through continuous impact. Measured gypsum is added to control cement setting time. Fine cement powder forms as grinding continues inside the mill. Oversized particles return to the mill for further grinding. Air separators classify cement particles by required fineness.
Pneumatic systems transport cement powder toward storage silos.
Finished cement powder exits the mill through sealed outlets. Cement quality is continuously monitored during grinding operations. Finished cement powder flows steadily toward silo storage areas. Cement grinding produces uniform powder ready for final storage.
Ground cement is prepared for controlled storage inside silos.
Finished cement powder enters tall storage silos for holding. Cement powder settles evenly inside the silo interior. Airflow prevents cement powder from compacting during storage.
Aeration pads inject air to keep cement free-flowing.
Silo-level sensors continuously monitor cement quantity. Automated valves control cement discharge from storage silos. Stored cement is released on demand for packing operations. Different cement grades are stored in separate silos. Cement powder flows from silos onto enclosed conveyors.
Quality checks ensure cement remains consistent during storage.
Cement powder moves toward automated packing and loading systems.
Weight checks ensure every cement bag meets specifications.
Cement powder is directed from silos to automated packing lines. Cement bags are sealed immediately after filling.
Filled cement bags move steadily along conveyor belts.
Rotary packers fill cement bags with precise, measured quantities.
Approved cement bags proceed toward palletizing stations.
Rejected bags are automatically diverted from the main line. Bulk cement loading systems fill sealed transport tankers. stretch wrapping secures cement bags for transportation stability. Robotic systems stack cement bags neatly onto pallets. Filled pallets and tankers await final dispatch procedures. Loading spouts control dust during bulk cement transfer.
Packaged cement is now ready for distribution and delivery.
Packaging lines operate continuously to meet production demand.
Packaged cement pallets move toward the dispatch loading area.
Cement pallets are positioned precisely onto loading docks. Forklifts transport cement pallets for truck loading operations.
Automated systems record cement quantities for shipment tracking.
Bulk cement tankers undergo final loading verification checks.
Cement bags are loaded carefully into distribution trucks. Sealed cement trucks prepare for departure from the plant. Dispatch teams coordinate outbound cement shipments efficiently. Cement trucks exit the factory through controlled security gates. Loaded cement vehicles merge onto regional transport routes. Finished cement products begin distribution to construction markets. The cement production cycle completes with successful dispatch. Continuous logistics ensure cement supply reaches project sites.